Welcome to the Perfect Squares and Powers of 10 video. So what I want you to do is think about what are the characteristics of a square. We know that they have a certain number of sides, and there are certain things that we know about squares. So I want you to think about that. And now I want you to think about what we did last class. Last class we learned about exponents. We learned about the base, and then we learned about the exponent. And we know that the exponent right here, we know that the exponent right here tells us how many bases we have. So in this case, this is 2 squared, so we have 2 2's. But if this was 3 squared, that would mean that we have 2 3's that we are multiplying. And 3 times 3 equals 9, or 3 squared equals 9. So now go back to think about what is a square and what makes a perfect square. So a square has to have all equal sides, and it has to have 4 equal sides. So this has 3 squares down, 3 down, and then 3 across. So this one here is a square. Now let's take a look at the other 3 pictures. These do not make a square, these here make a rectangle, and then these here make some other shape. So a perfect square is a number made by squaring a whole number. So for example here, 3 squared is 3 times 3, which equals 9. So 9 is a perfect square. So the learning target for today, at the end of this lesson, you should be able to say that you can identify a picture of a perfect square, determine if a number is a perfect square, and find the solution for a perfect square that is an exponential notation. And that means that it would be 3 squared. That is exponential notation. And then at the end of the video, you will be learning the patterns for the positive and negative powers of 10. So what we want to do now is we want to make a 1 by 1 perfect square. And that would just be a 1 by 1. So 1 times 1 equals 1 square. Okay, so there's the 1 square. Next, we want to make a 2 by 2 square. And that has the area of 1, 2, 3, 4. So 4 squares. And there it is with the squares made. Next, we need to make a 3 by 3 square. Okay, and there we get 9 squares. 3 times 3, or 3 squared, is 9. Here we have 4 squared, so I'm going to draw a box of 4 by 4, and that would be 4 times 4 equals the 16 squares that we have here. So there's our 16 squares. Then we can make a 5 by 5. So a 5 by 5 square has 25 squares. And then we can make a 6 by 6. Which would be 36 squares. We can make a 7 by 7, 8 by 8, 9 by 9, 10 by 10, which is 100 squares. So a square has 4 equal sides. So all the sides are the same length. When we talk about perfect squares, we are referring to the area of the square. And the area is how much space is inside the square. And we find the area by multiplying the length times the width. So we are multiplying a number by itself. So let's take a look at a square here. We have the length and the width. With a square, these are the same number. So if this was a 4 and this was a 4, we would be saying 4 times 4, which is also 4 squared, and that would be 16. So here we have a 2 by 2, so that is 2 squared, and notice we have 4 squares, or 4 little circles inside there. Here we have a 3 by 3 square, so that's 3 squared. Here we have a 4 by 4, so that is 4 squared. Here we have a 5 by 5, so that is 5 squared. And at the end we have a 6 by 6, which is 6 squared. And we're going to go through and solve these. So 2 squared is 4, 3 squared equals 9, 4 squared is 16, 5 squared is 25, and 6 squared is 36. So there are 20 perfect squares. That you need to be able to use and recognize. And what I want you to do is pause the video and see if you can fill these out. Okay, welcome back from pausing the video. So now what you should have is all of your perfect squares. So if you did attempt to do these, as I had asked you to, please verify that you got these correct and pause the video again if you need to. So one thing I want to point out is 1 is a perfect square. You can have a 1 by 1 square, and students often forget that. So please make sure that you know that 1 is a perfect square. Okay, here are all your perfect squares up to 10 times 10, or 100. Here are your perfect squares 11 through 15. And here are your perfect squares 16 through 20. And one way that you can memorize these would be to make flashcards, and I would encourage that because this is something that you should be able to know and recognize. While you do get a calculator on your exponents, when we get to order of operations, you do not get a calculator for anything with order of operations, and exponents is part of that. Usually we will use perfect squares. All right, so what I want to go over now is your powers of 10. So powers of 10, notice at the top of the screen, right up here, we have 10 to the 0 power. Anything raised to the 0 power is just 1. And then the next one, we have 10 to the 1st power, and that would be 10. 10 to the 2nd power means 10 times 10, which is 100. 10 to the 3rd power means 10 times 10 times 10, and that is 1,000. All right, now we've got 4 tens that we're multiplying, and that is 10,000. Next, we have 5 tens that we're multiplying, and that would be 100,000. Okay, next we have 6 tens we are multiplying, and that is 1 million. And this should have been a 10 to the 7th, so we have 7 tens that we're multiplying. And on that one we get 10,000. Okay, so here are your notes. What I want you to do is I want you to fill in 10 times 10 times 10 each time on the first line, and then I want you to write the answer. There is a pattern. Whatever the exponent is, that's how many zeros there are after the 1 for positive exponents. So what I'm going to do is I'm going to go ahead and I'm going to fill out the first one with you. So 10 times 10 times 10 times 10 times 10 times 10 times 10. So the answer is going to have 7 zeros. So that is 10 million. All right, the next one, we're multiplying 6 tens. And that is going to have 6 zeros, so that is 1 million. Okay, the next one, we are multiplying 5 tens. Or we have 5 zeros. So that's 100,000. Next we have 4 tens. And that is 10,000. Next we have 3 tens. So that is just 1,000. Next we have 2 tens. So that is 100. Next we have 1 10, so that's just 10. And finally we have no tens. Anything raised to the 0 power is just 1. Now, just as there's a pattern when we do positive exponents, there's the same pattern for negative exponents, but we're going backwards. Okay, so 10 to the negative 1 is going to have 1 0, but this is going to be less than 1. So it's 0.1, okay? The next one is going to have 2 zeros, but there's only ever 1 0 before the decimal. Okay? The next one is going to have 3 zeros. And finally, the last one will have 4 zeros. Okay, so what I want you to look at now is, notice that I didn't say 10 times 10 times 10. That's because what we need to do is we need to go back and review how we say these, okay? So this is 1/10. There's a 1 in the tenths place. So it's 1/10. All right, the next one is 1/100th, and we would get that by saying 1/10 times 1/10. The next one is 1/1000th, and we would get that by saying 1/10 times 1/10 times 1/10. And the last one would be 1/10,000th. So we'd get that by 1/10 times 1/10 times 1/10 times 1/10. All right, now the positive exponent tells you how many zeros you have after the 1. The negative exponent tells you how many zeros you have before the 1. This includes the 0 that is before the decimal. The negative does not make the answer negative. Notice all of our decimal numbers are positive. All that the negative does is tell us that the answer is less than 1. Okay, if you need to, go ahead and pause the video now so that you can copy this, or you can go ahead and move on. All right, so let's review. This is read 1/10. The next one is read 1/100th. The next one is 1,000th. And finally, the last one is 1/10,000th. Okay, so what I want you to do is go ahead and pause the video or stop the video here, and I want you to see if you can finish the rest of this on your own. And then here we have all of the answers filled out. So if you need to, go ahead and pause the video here so that you can verify your work, and then I will see you tomorrow in class. Have a wonderful night.